Now let us solve some examples. These are solved examples from your textbook. First example is a sound wave has wavelength 1.5 meter in a gas and 0.8 meter in air. Calculate first frequency of sound, second velocity of sound in gas if velocity of sound in air is 340 meter per second. Now let us start solving. Here we will write data. Remember how to write your problem. Means there is a way of writing or solving the problem. So firstly you have to write the data. Data is given things. So first one, wavelength is given inside the gas, so that we can write it as lambda 1. It is 1.5 meter. Then second, wavelength is given inside the gas, means sound wave has wavelength 1.5 meter in a gas and 0.8 meter in air it is given. So inside the air we can write lambda 2, it is 0.8 meter. Then it is mentioned we have to find velocity of sound in gas. That means we have to find V1, and velocity of sound in air is given as, so I can write directly V2 here. It is 340 meter per second. Why I am not writing V1 here? Because to write V1 we have to write to find, because we have to find that quantity. So to find here we have to find V1, that is velocity of sound in air, in gas. Air is given. So now let us write down the formula here. Formula was V is equal to, if you remember, it was nu into lambda, where nu is the frequency and lambda is the wavelength. So let's start solving. So solution. Now the same formula I can utilize for two cases here. Means we can write V1 is equal to nu1 lambda 1, V2 is equal to nu2 lambda 2. Now here in this case, frequency of the wave will not change because the physical state, means physical conditions are not same. Hence in both the mediums, in gas as well as in air, the sound will travel with the same frequency. So now here we have V2 and lambda 2. So I will write V2 is equal to nu2 into lambda 2. But as I mentioned, frequency will not change, so I can rub this 2 factor here. So substitute the values, means we know V2, we know lambda 2, so we can find nu. So nu will be V2 upon lambda 2. So V2 is 340 and lambda 2 is 0.8. So I will get the value of frequency here. On calculation, the frequency you will have, it will be 425 Hz. This is not asked, but this is required to find out V1. So V1 we will write V1 is equal to nu into lambda 1. So let us substitute the values. Now my nu is frequency, it is 425. Lambda 1 is 1.5, and on multiplying you will get V1 is equal to 637.5 meter per second. Don't forget to write unit, otherwise half mark will be deducted. So box your answer, and lastly you have to write it properly. So answer, the speed of the sound in gas is 637.5 meter per second. In this way, lastly you have to write down your answer. Now let us move towards next example. Our next example is calculate distance travelled by a sound wave having frequency 1000 Hz and wavelength 0.25 meter if it travels for 5 seconds in a certain medium. So this is the this problem is based on distance formula. If you remember, distance was equal to velocity into time. Now let us write down the data here. Here frequency is given, so it is nu is equal to 1000 Hz. So frequency is 1000 Hz. Then wavelength is given, that is lambda is given, it is 0.25 meter. Then time is given here, it is 5 seconds, so we can write it as small t. And here we have to find distance, that we will say small d. Now we will write the formula. Now in order to find distance, we need velocity and time. So time is here, but we don't have velocity, but we have frequency and wavelength. So from frequency and wavelength we can find velocity. So here our first formula will be V is equal to nu lambda, and second formula will be, that is formula of distance, it will be velocity into time. So let's start solving. So solution. Now for velocity rewrite the formula. Now substitute the values. Nu is 1000 and lambda is 0.25. So you will get velocity as, on multiplying, 250 meter per second. Now for distance, rewrite the formula again. So distance is equal to, velocity is 250 and time given is 5 seconds. So on multiplying distance you will get, it is 1250 meter. Box your answer. And lastly you will mention the distance is equal to, distance is 1250 meter. So this is the solution. Now next example is our third example. It is the audible range of sound is 20 Hz to 20,000 Hz. At 22 degrees Celsius in air, speed of the sound is 344 meter per second. Express the range of the sound in terms of wavelength by calculating respective values. Now this is the general situation. In the range of human ear, means range of hearing of human ear, we had learned about this. The range of human ear is 20 Hz to 20,000 Hz. Means this is our capacity. Now this capacity is expressed in terms of frequencies. Now this we have to express in terms of wavelengths. So let us write down the data. Now we can write first lower frequency as mu1, which is 20 Hz. Second higher frequency mu2, it is 20,000 Hz. Velocity of sound in air is given 344 meter per second, and we have to find corresponding wavelengths. Means for mu1 corresponding wavelength will be lambda 1. For nu2 corresponding wavelength will be lambda 2. So these two values we have to find out. Now the formula we will use here, definitely the formula of velocity, which is related to frequency and wavelength. Now let's start solving. So here we have solution. Now we will rewrite the formula. For that purpose, firstly we have to find out the wavelength. Now according to this formula we can write V1 is equal to nu1 into lambda 1. But here we will keep V as, means V1 as V only. So we will find lambda 1 accordingly. So lambda 1 is equal to V upon nu1. So let us substitute the values. Now V is 344 and nu1 is 20 Hz. So lambda 1 will be 70.2 meter. Now here I am not taking V1 or V2 because the medium is same. So velocity of light in air will be similar. So for lambda 2, again we will write V is equal to nu2 into lambda 2. So here lambda 2 will be V upon nu2. So lambda 2 is equal to 344 upon 20,000. So lambda 2 will be 344 upon 20,000. So after dividing you will get it as 17.2 into 10 raised to minus 3 meter. So this is the second wavelength. So box your answer. And here according to question you will write it in proper words. That means here I am writing answer, the audible range of sound is from 17.2 meter to 17.2 into 10 raised to minus 3 meter. So this is your answer in terms of wavelengths. Now let us move towards our next example. It is fourth example. It is a child shouted hello near a chief and heard the echo from some time. If the speed of the sound is taken as 345 meter per second at respective temperature and the distance of chief from the child is 690 meter, calculate time after which echo is heard by the child. Now this is very simple example. In echo only we had calculated or we had derived the formula for it. That simple formula, velocity is equal to distance upon time or distance is equal to velocity into time. So let us start solving. Write down the data first. So here data, here the speed of the sound is given. So V is given and it is 345 meter per second. Then distance travelled by the sound is also given. So it is D and it is 690 meter. Here we have to find time travelled by the sound. So which is T. So formula this means formula here that we will use will be distance is equal to velocity into time. Now let's start solving. Now here total distance travelled by the sound will be distance from the child to shift plus distance from the shift to child. So that will be, actually we have to double our actual distance. So in the data only I will multiply it by 2. So our actual distance will become, it will be 1380 meter. So this is the actual distance. So now we have to find distance, means we have to find time. So according to this formula of distance, we will rotate it. So formula for time will become T is equal to D upon V. Since I am using small d for distance here, I have written accordingly. So this is distance upon velocity. So let us substitute the values. My distance is 1380 upon velocity given as 345 meter per second. So on division you will get T, which is 4 seconds. So this is your answer. So in the answer you will mention it properly. Echo is heard by the child is 4 seconds after shouting. Echo is heard by the child is 4 seconds after the shouting. So this is your answer. Now we will solve exercise problems from your exercise of textbook. This is your first problem, means question number 3, problem number 1. It is a sound wave has a frequency 320 Hz and wavelength 0.25 meter. How much distance will it travel in 10 seconds? So we will write data here. Here frequency is given. So nu is equal to 320 Hz. Then wavelength is also given, that is lambda. It is 0.25 meter. Then time is given, it is 10 seconds. Now we have to find distance. So formula that we will use. Now the formula of distance is, it is velocity into time, but for finding the velocity we have to use the formula of velocity of sound, that is v is equal to nu lambda. So firstly we will use this formula, and after that we will use the formula of distance, which is velocity into time. So let us start solving. So here we have solution. Firstly, rewrite the first formula. So it is v is equal to nu into lambda. Let us substitute the value. Nu is 320 and lambda is 0.25. So on multiplying you will get v is equal to, that is velocity, it will be 80 meter per second. Underline this. Now to find out the distance which is asked, we will rewrite the formula of distance, that is velocity into time. Now here velocity we got, it is 80, time is given 10 seconds. So distance is equal to 800 meter. Box your answer and in answer write it properly. Distance travelled by sound wave is 800 meter. So this is your first problem. Now let us move towards our second problem from exercise only. It is a sound wave having certain frequency travels with a speed of 336 meter per second and wavelength 3 centimeter. Calculate the frequency. Will it be audible? Means here we have to find out the frequency of the sound, and definitely according to frequency we will decide the sound is audible or not. So let us write down data here. Here speed of the sound is given, so it is 336 meter per second. Wavelength lambda is also given. It is 3 centimeter, so we will convert it into meter, so it will be 0.03 meter after dividing by 100. Now we have to find nu, that is frequency, and whether sound is audible or not. So in the formula, definitely we will use this formula, velocity of sound in the form of frequency and wavelength. So V is equal to nu lambda. So now let's start solving. So here we have solution. V is equal to nu lambda, rewrite the formula. Then here we have to find out the frequency, that is nu. So nu will be V upon lambda. Let us substitute the values. Now my V is here 336 upon lambda, which is given as 0.03. So on calculation you will get the frequency as, it is 11,200 Hertz. Box your answer. Now the audible frequency is between 20 Hertz to 20,000 Hertz. Definitely, therefore this value lies in between 20 to 20,000 Hertz. So this is the audible frequency. So in the answer you will write the frequency of sound is 11,200 Hertz, since it lies in the range to 20,000 Hertz. It is audible. So this will be your answer. Now we will solve the exercise. Here first question from the exercise is fill in the blanks. In that first fill up is the sound waves need dash medium for propagation. The answer is material. So the sound waves need material medium for propagation. So you will write the answer and double underline it so that it will be more visible. Then second fill up is technique of echocardiography is based on reflecting property of dash waves. Now definitely here we are learning about sound, so answer is sound waves. So again you have to double underline your answer. Next fill up is sound produced by vibration of simple pendulum is dash sound. Now here simple pendulum, you know, as I have explained you that bob having string is a simple pendulum. Now the vibrations produced by the pendulum are of very lower frequencies, so those vibrations are infrasonic vibrations. So that sound is infrasonic sound. So your answer is infrasonic. So you will write in this way. Next fill up is for determination of the depth of the sea, dash technique is used. You must remember the ship I had drawn. So definitely for measuring the depth, sonar technique is used. So your answer is sonar. Write it in the capital letter since this is the abbreviation. Then next fill up is pitch of a sound depends upon dash of the wave. Pitch of the sound definitely depends upon the frequency of the wave. So answer is frequency. So first question is finished. Now second question is answer the following. In that first question you have, suppose you and your friend are on the moon. With you means will you be able to hear any sound produced by your friend? Give reason. So this is very simple question. Here you have one condition that you and your friend are on the moon and you have to try to listen the sound which is produced by your friend. Now here is your answer. Now I will dictate you point wise. You have to write in that way only. First point here, no, we won't be able to hear any sound produced by our friend on the moon. Second point, this is because sound require a material medium for its propagation. Third point, on the moon there is no air but only vacuum. Fourth point, hence sound cannot be heard on the moon. Here I will explain you. On the moon there is no atmosphere, so that means there is no medium for transmission of sound. So sound cannot travel, so we will not hear any kind of sound on the moon. So this was your first answer. Second question is, it is why we cannot hear echo produced in our classroom. Now here you have another condition. You are sitting in your classroom and you are trying to hear echo produced by the noise or by the sounds of your own friends or classmates, but here we can't hear the echo, so we have to write the reason behind it. So I'm dictating the answer point wise, so note it down. First point, to hear distinct echo at 22 degrees Celsius, the minimum distance required between the source of sound and the obstacle should be 17.2 meters. Second point, in a classroom, the ceiling is not so high and the distance between the opposite wall is usually less than 17.2 meter. Hence, the sound is not reflected, means we can't hear, means sound is reflected but echo we can't hear there. So hence we cannot hear echo produced in our classroom. So this is your second answer. Now let us move towards third question. The question is, why are ceilings of concert halls and cinema halls curved? Means they are not straight, they are curved. Why is it so? Answer is, ceilings of concert halls and cinema halls are curved to avoid the undesirable reverberation, otherwise pitch of the sound will not be heard distinctly. I will explain you the answer. Here, if ceilings are not curved, if they are straight, then sound will be reflected and definitely there will be continuous reflection of sound. So we will not able to distinct the by the source. That's why in order to hear loudness and clearness of the sound, ceilings of the cinema halls and concert halls are curved. The next question is, which type of waves are sound waves? State their characteristics. Here I am dictating the answer, note it down. Sound waves are longitudinal waves propagating through a medium. For example, solid, liquid or gas. Medium may be solid, liquid or gas. The characteristics of sound waves are: first, compression and rarefaction; second, wavelength; third, oscillation; fourth, frequency; fifth, time period; sixth, pitch; then seventh, amplitude; eighth, loudness; and ninth, intensity, etc. All these characters I have explained you in the chapter. So this is your answer. If you want, you can elaborate each term. That means you can write down the definition of wavelength, definition of oscillation, definition of amplitude and all. Then our next question is, explain auditory aspects of human ear. Now let me tell you, in this particular question you have to draw the diagram of human ear. So firstly you will draw the diagram of ear and then you will start writing the answer. Now first point in this, human beings hear sound through ears. Second point, it converts pressure variation with audible frequencies into electrical signals that travel to the brain via auditory nerve. Third point, there are three major parts of the ear: external, middle and inner. Fourth point, the external part called the pinna collects the sound which is carried by auditory canal to the eardrum. Fifth point, the eardrum is a thin membrane. Sixth point, it is set into vibration due to the sound reaching it. Seventh point, when compression of a medium reaches the eardrum, the pressure outside the membrane increases and forces the eardrum inwards. The eardrum means, my next point is eighth point, the eardrum moves outwards when a rarefaction reaches it and eardrum vibrates. Then our next point, it is ninth point, is the vibrations are amplified and carried to the inner part of the ear. 10th point, a part of the auditory nerve connects the part of inner ear to the brain. The 11th point, there is a spiral chamber like snail's shell inside the inner ear called cochlea. Then 12th point, it is responsible for recognizing the qualities of the sound, that is loudness and pitch. Next point, that is 13th point, in cochlea the vibration received from the eardrum are converted into nerve impulses or electrical signals which are sent to the brain through the auditory nerve. Then 14th point, the brain then interprets them as a sound. Last point, the amplitude of vibration of membrane gives the brain a measure of loudness of sound being heard. So these 15 points you have to write, and lastly you will draw the diagram that I had drawn on the board during the chapter. So this is your answer. This is quite bigger answer. It will carry 4 to 5 marks in the examination. Then we will solve next question. Next question is question number 4 from your textbook. Now question number 3 is of problems that we did already. Now here question number 4 is you have to match the columns and rewrite it after matching. So here directly I have written the answer. In the first column, first content was transverse wave. Now for transverse wave, particles oscillate perpendicular to the direction of propagation is the correct match, and in the third column the correct match is wave produced in a string. Then in the second, the content was longitudinal wave. So for longitudinal wave, the correct matchup from column 2 is particles oscillate parallel to the direction of propagation, and its example is here wave produced in a slinky. Now the third content in the column 1 is ultrasound. So as you know, ultrasounds are high frequency sounds. So it is high frequency wave, and the correct matchup from column 3 is frequency greater than 20,000 Hz. Fourth one is infrasound. Again, infrasounds are the sounds of low frequency. So low frequency waves, and next matchup is frequency less than 20 Hz. Last one, it is audible frequency. Correct matchup for it is echo formation is heard under particular condition. Then frequency between 20 Hz and 20,000 Hz. So this is the correct matchups. Now next question is question number 5. It is write short notes on. In that, our first short note is ultrasound. Now here I will dictate you the answer. You know ultrasound very well. These are high frequency sounds having frequency greater than 20,000 Hz, and particular animals only can hear those particular sound. So here we will write about it. So my first point of answer is sound waves having frequencies greater than 20,000 Hz are called ultrasonic sounds or ultrasounds. Second point, the special property of ultrasound is that they are able to travel along well-defined path even in the presence of obstacles. Third point is it is produced by dolphins, bats, rats, etc. in nature. Fourth point, moths of a certain families can hear the ultrasound produced by bats, and they can protect themselves from being captured by bats. Last point, ultrasounds are used in industries, ships, echocardiography, welding plastics, ultrasound scanners, etc. So these 5 points you have to write. In the last point we had written applications of ultrasound. Then our next short note is sonar. Now in this again you have to explain the sonar system. In that we had studied the example of ship finding the depth under the sea level. So first point here is sonar is an acronym for sound, navigation and ranging. So in the first point you will write down the full form of the word sonar. Then second point, sonar measures the distance, direction and speed of the underwater objects using ultrasonic waves. Third point, sonar consists of a transmitter and a detector which is installed in a ship or on a boat. Next point, the transmitter produces and transmits ultrasonic waves which travel through water. Last point, they get reflected after striking the objects on the seabed. Then here, if you want, you can draw the diagram of ship that we had drawn during the chapter, and also you can write down the formula for measuring the distance of the object from the sea or under the sea level. In the last point you can also mention the reflected waves are sensed by the detector. So this is the answer. Then our next short note is reverberation. Now here is your answer. First point, repeated reflection of sound waves from the walls in a room combine to form a continuous sound. Second point, this results in the persistence of sound called reverberation. Third point, the time interval between the successive arrival of the same sound signal goes on decreasing. Next point, also the intensity of sound gradually decreases. Next, fifth point, but these reflected sound interfere and cause jumbling and prolongation of sound in the room. Last point, due to this pitch, music will not be heard distinctly or sound will not be heard distinctly. So this is the explanation of reverberation. These particular short notes carries 2 to 4 marks depending upon the length of the answer. Now last question is very simple. You have to define some terms. In that, my first term is wavelength. So here is your definition. The distance between two consecutive compressions or two consecutive rarefactions is called wavelength. Second, it is frequency. Here is the definition. The number of oscillations per unit time is called frequency of the wave. The next thing, one thing I have to mention, if you want, you can also write symbols. For wavelength you can write lambda, for frequency you can write nu. Then next definition is amplitude. In the bracket you can mention capital A. The definition is the magnitude of maximum displacement of the particle in a medium on either side from the mean value. Next is amplitude. In the bracket you can write capital A. The magnitude of maximum displacement of a particle in the medium on either side of the mean value is called amplitude of the wave. So here is the definition of amplitude. Our next definition is echo. Now here you will write echo is the repetition of sound due to reflection of original sound from any surface. So these are the definition. So in this way we complete our chapter with exercise.